Assalamualaikum Doctor, my name is Nurul Zatanani binti Hamran from AS253 and I'm under supervision Dr. Noviki Bihot. Today I'm going to present my final year project entitled Phytochemistry and Pharmacological Activities of Cussonia species, a comprehensive review. This is the outline of my presentation today. The objective of this study is to review comprehensively about Cussonia genus, which starting from 1993 until 2022 in regards to traditional application, phytochemicals and biological activities. The research question for my review are to know the relationship between the existing phytochemicals and pharmacological activities possessed to efficiently demonstrate the traditional application. Second is whether this review able to describe the research insight, existing gaps, and the future research direction in pharmacology field. And the last one is, will members of pharmacological field find this paper useful? Before we jump right into our discussion, let's take a look at the distribution of this genus first. The genus of Cussonia currently consists of 20 species. 19 species are widely distributed in Africa, meanwhile one species, Cussonia hosti, is located in Arabian Peninsula, Yemen. The common topographies where this genus can be found are in tropical forests, woodlands, savannas, grasslands, and humbos. There are three highlights in this review, as mentioned before, which are traditional uses, phytochemicals, and biological activities. From the genus gathered, only information of 11 species of Cussonia are available. The plants are often used as a source of food or as a remedy to treat various range of ailments. For example, powdered bark of C. arborea, orally taken to neutralize the snake venom. Second, fresh leaves of C. hosti are crushed and put on burns. Third, boiled roots of C. zimmermanni are gargled to stop gum bleeding and bewitchment. The chart was provided to simplify the numerous traditional uses. From there, we can see that C. panniculata and C. spicata are mainly used by the old folks in their daily lives. There are 48 phytochemicals isolated from 8 Cussonia plants. The 48 phytochemicals are in 7 different types of groups. Based from the findings, triterpenoid saponin are highly present in Cussonia plant, which are 39.6%. From the research, there are 16 species that has been studied and reported for their biological activity. The efficiency of biological activity, or what type of activity it possesses, are different based on the species, the part of plant, and what type of extract used. For example, first, of C. spicata. When using hexane extract, antibacterial activity are only shown against B. subtilis and E. coli. However, when using ethanol extract, it only against S. aureus. Second is root of C. spicata. When using ethanol and ethyl acetate extract, the antibacterial activity are both against S. aureus and works more efficiently compared to the reference drug neomycin. There are 8 biological activities reported, such as antimicrobial activity, anti-cancer activity, anti-diabetic activity, anti-inflammatory activity, antioxidant activity, immunomodulatory activity, sedative activity, and toxicity. So, what's the correlation between all those three? General idea for this correlation can be simplified like this. The old folks claim the uses of the plant. Next, the researcher needs to prove the claim by evaluating what activity that the plant possesses. If indeed the plant have that activity, what phytochemicals are responsible for that activity? In accordance to the three highlights and information obtained from a true study, only 4 species fulfill this correlation, which are C. arborea, C. bancoensis, C. hosti, and C. zimmermanni. From there, only 4 biological activities that are involved, together with 6 responsible phytochemicals. Phytochemicals 24 and 45 are isolated from C. arborea. The elders claim that C. arborea can be used as a sedative, which it is proved by the presence of sedative activity in mice. And compound 24 is responsible for this activity. Meanwhile, for compound 45, immunomodulatory activity is observed based on the RS and T cells proliferation, which proved the claim made by the old folks to neutralize the snake venom. In C. bancoensis, compound number 27 is responsible for the plant to show the antibacterial activity against S. aureus, S. pyogenes, E. faecalis, and S. typhi. The respiratory tract infection caused by S. aureus and S. pyogenes can be cured by C. bancoensis. Gonorrhea is sexual transmitted infection which can be caused by T. vaginalis. Compound 38 possess antiparasitic activity against T. vaginalis, thus prove the claim. Leishmania dovani cause an illness called leishmaniasis. This disease can cause fever, affects liver, spleen, and bone marrow, and if left untreated, the infected person will die. Both compounds 3 and 4 possess anti-leishmanial activity, which can be used to cure the infected person. In conclusion, a detailed compilation of these 3 highlights are significant, since the phytochemicals present in this plant are shown to exhibit the pharmacological activities, which justify the use of traditional medicine. Since there are only 4 species that can fully correlate, this can open enormous opportunity to further investigate this genus. It is not impossible to establish Cussonia plants as a potential source of novel drugs. That's all from me. Thank you.